All right, so we're starting a new unit here based on something that are called conic sections. Conic sections are different ways, exactly as their name implies, different ways that you can slice a cone. Conic coming from cone, sections meaning cross sections. So what you're looking at here is how these different two-dimensional shapes come from a three-dimensional concept. All right? If you take a cone, a three-dimensional cone, and you slice it parallel to its base, so if the base is here and you slice it parallel and you look down on that shape, you would be looking down on a circle. If you slice on a bias, so if you had a flat base and you sliced through on a bias through the edges of the cone, you would get, and you look down, you would look at this oval shape. That's what's called an ellipse. If you slice through one side of the cone and go through the base of the cone and look down, you would be looking at a parabola. That's where we're going to start our discussion today, and then the hyperbola, which we'll talk about later. We're going to start our discussion talking about parabolas, then we're actually going to circle back around to circles and ellipses. So I'm going to start with this GIF about what a parabola, how a parabola can be formed. I'm going to do a little bit of talking as this animation is going because I can't stop it. Okay? But what it comes down to is the two main physical concepts that are important about a parabola are the focus and the directrix. So this red line that you can see down here on the bottom is a fixed line. It's either a horizontal or a vertical line. The focus is a point. Now you can see the distance from the focus to the directrix is important because halfway between there is the vertex of the parabola. So what you'll see as this thing keeps reloading is when you have a focus and a directrix, you find this distance, halfway is the midpoint. That's why they're saying that this length and this length are equal. And if you fixed that point, if you took that vertex and you stretched it out, and took the distance between the focus and the directrix, every single point as you see this slide up, these two distances are the same. These two distances are always the same, and that's the definition for what a parabola is. Okay? So a parabola, by definition, and I'm going to write this down so you should too, a parabola is a set of points whose distance is the same from a point that we call the focus and a line. And that line is what we call the directrix. Funny name, I get it, but that's what a parabola is. My drawing is a bit more crude, but we're going to try to accomplish the same idea. Okay? So you can see this dotted line right here. This dotted line is what we would call the directrix. So you should have these notes with you as you're looking at this video. The anatomy of a parabola. We want to understand the physical characteristics of this shape. The directrix is this fixed line. This point, I'm calling that on the inside of the parabola, even though the parabola extends forever, so it's technically not a closed shape. I'm calling this the inside of the parabola. And that point that's inside the parabola, that's called the focus. Okay? So we have the directrix down here, we have the focus here. Halfway in between the focus and directrix, that's where the vertex is. Okay, so the vertex of the parabola is the midpoint between the focus and directrix. Now what's going to start to become really important is this distance. Now this distance right here, okay, which is again the same as this distance right here, we label that distance as p, the lowercase variable p. Okay, so if you need a definition, p is the distance from the vertex to the focus. All right, and think of p almost like you think of m in terms of the slope. It's a physical, it's a variable that represents a physical characteristic on the graph. Right? Now, every single one of these points, when on this parabola, what we're saying is, if you find the distance, all right, change it up. If you find the distance from the focus to that point, it should be the same as the distance from that point to this line. We're saying that these distances should be the same based on this explanation of what a parabola is. So when we talk about parabolas from now on, it's not just going to be like, oh, it's the graph of a quadratic or it's x squared. It's going to be a lot more than that, right? We've defined it in terms of its physical traits here. We're talking about the p-value, which is going to be pretty important going forward, okay? And every single one of these points here, right, we're going to label each one of these as xy. Any point on the parabola is xy. We've talked about the vertex before. We had a name for this in the past when we were in chapter 2. I don't know if you remember, but the vertex, which is right here, has coordinates h and k. So this is what I call the anatomy of the parabola, understanding all of the physical traits. Oh, the one thing I forgot, sorry. The one thing I forgot is that axis of symmetry, which we've discussed before as well when we were in chapter 2. That line that passes through the focus and the vertex is known as the shortened version, we're going to call that the axis, right? This line that's cutting through the middle, the axis of symmetry. So this is, and these are terms that you're going to hear me say quite a bit in some of these other videos. You're going to hear words like focus, directrix, axis, vertex. All of these words have meaning to the physical state of the parabola. More to come in that in the next video.